Well, hello everyone. This is week five's topic. It's a single section, section 3.2. There's quite a lot in it, and it's to deal with polynomials. And over the next three videos, we're going to cover an introduction to polynomials. Basically, what do their shapes look like, end behavior, sketching the functions, and then how to do a detailed sketch of them. So I'm going to go straight into first topic, which is introduction. So what is a polynomial? Well, a polynomial is a function that consists of positive powers of x. Positive consists of positive whole number powers of x. So for instance, a typical polynomial might look something like this. 7x cubed minus 3/4 x squared plus 0.1 x minus 3. Now, if you notice the numbers at the beginning, these are called the coefficients, can be anything. They could be whole numbers, fractions, it could be negative, they could be decimal. That has no effect on whether or not a function is a polynomial. All that matters is x cubed, positive power of 3, x squared, x's, and negatives. This is typically how a polynomial should be written, which is from the largest power of x down to the smallest. So since this is an introduction, and what we're going to be doing right now is looking at this and getting you used to the terminology. So here's our first one. The largest power of x is called the degree of the polynomial. So in this case, we would say that the degree of this polynomial is 3. We don't say its degree is x cubed, and we definitely don't say its degree is 7x cubed. All you mention when you describe the largest power of x, the degree of a polynomial, is to tell me what the power is. Now, these numbers at the front of various powers of x, and this guy here, they have names. Let's do him first. Sometimes a polynomial may finish with a +2, a -0.5, and so on. In this case, it's -3. We call that number the constant term. These numbers, the ones that are associated with a particular power of x, we would call these the coefficients. So for instance, 7, which is part of x cubed, the 7 part, we call that the coefficient of x cubed. This here, for instance, would be, so we'd say the coefficient of x cubed is 7, right? Just a number. Here we would say the coefficient of x squared is -3/4. Here we would say the coefficient of x is 0.1. So there's some terminology to get used to. Let's give you some examples of some functions, some of which will be polynomials and others won't be. So for instance, 5x squared minus 3 is a polynomial. In fact, it's a polynomial of degree 2. Now, a couple of things. Have you noticed that there's no x term? There doesn't need to be. There just needs to be whatever terms are there, all contain positive whole number pairs of x. Now, you might think, well, 3 doesn't have a pair of x. Well, I guess the way it's written, it doesn't. But if you think of it as being 3x to the 0, it now does. That's not a polynomial. In fact, this is a rational function. Have you noticed that the previous one is a polynomial and its degree is 2? But secondly, did you notice it's also quadratic? 3x take away 7 is a polynomial. In fact, it's a polynomial of degree 1. The square root of x squared plus 1 is not a polynomial. In fact, it's a radical. Continuing along this theme, sometimes you can be caught out. That is a polynomial. And you might say, but it's a rational function. Well, I guess the way it's written is a rational function, but it's not necessarily the way that's originally written decides if it's a polynomial, because you can rewrite this which in turn becomes that. And now you can see clearly that it is a polynomial. And its degree is 3. Now, looking at this guy, I hope you can look at it and say, yeah, it's a polynomial. And if you wanted to find out what it is, you could FOIL it out. So it is a polynomial. And its degree, you'll have to trust me in that, is 3. And to do that, you would FOIL it out and get what you've got. So let's now look at how do you find the degree of a polynomial? Okay, so what we're going to do now is look at how do you find the degree of a polynomial? Right, here's a straightforward one to start the process. So what we have is essentially a quadratic, but we recognize that as a polynomial. And the highest power of x is 2. So this is a polynomial of degree 2. However, you're not always going to get things written in a format that is easy to deal with. Now, I guess I could FOIL that out. It wouldn't take too long. But there is a way to actually figure out what the degree is. Since it's only going to be the largest power of x that you get, then I recognize that this times this is essentially going to be x squared times 2x. That's essentially going to be the biggest power of x. So I can now look at this and see that its degree is in fact 3. Now, suppose you had x squared minus 1 cubed times x plus 1 squared. And again, you wanted to find the degree of this polynomial without having to fight your way through a whole lot of horrible algebra just to find out the whole polynomial written out in its standard form. Well, what I would do is I say, look, x squared cubed. That's going to get you an x squared cubed, right? It's going to get you an x to the 6 and a whole load of other stuff, which I don't care about because they're going to have a smaller power than that. An x squared plus 1, or x plus 1 all squared, that's going to get me an x squared. And so what we're going to get here is basically an x to the 8. So our polynomial is going to be degree 8. Now what I'm going to do now, and basically that's it. So what I'm going to do now, to finish this first piece of the work, number 1, introduction, is that we're going to look at what do the basic sketches of polynomials look like. Well, the basic building block polynomials, you could have a guy like y equals x. You could move up, and the next guy you would get was a guy that we've seen before. That's what the polynomial of degree 2, the basic building block one at least, would look like. If you move up yet another one, you get y equals x cubed. And for completeness sake, let's just do one more. And if you do y equals x to the 4, it looks pretty much the same shape, just a little bit, vertically kind of bigger. And that is x to the 4. So with the exception of y equals x, the basic building block of a single power of x, an x squared, an x cubed, an x4, x to the 7, they boil down to just two shapes. There's the ones that have an even degree, and I'm talking about starting at x squared and then x to the 4 and then x to the 6 and all the other ones that come like that. And all of those are basically that shape. Which, if you think about it, is what an x squared looks like. And that's because x squared is a polynomial of an even degree. Now, if you do an odd one, you would get some that looks like this. And if you're talking about polynomial of odd degree, you're talking about, an x cubed, an x to the 5, an x to the 7, and so on. Y equals x is a special case. Technically, so is y equals 10 a polynomial. It's just a polynomial of degree zeros, but they're not very interesting, so we won't spend any time on those. So if I know the basic shape of a building block, it then means I can use our friend transformations to do sketches, very basic sketches, of polynomials if they're written in a very specific form. So for instance, if I did x minus 4 cubed plus 1, and I would like to know what that would look like as a very basic sketch. Well, I would start off, and I'll do it in little dotted, because there's going to be a lot of diagrams here. I'd start off with my basic building block shape, which is x cubed. And hopefully we can recognize that you start with an x cubed, and then you move it to the, well, what? Left or right by 4. What do you think? Left or right by 4? You move it to the right, correct? And then you move it up 1. So for a shape like this, I would probably focus on that point there. Because if I can move that point, the rest of the shape kind of follows it. So if you move it to the right, 4, and then you move it up 1, it's now there. And then you try your best. And it's a bit difficult to do a really good version of this, but you try your best. Then you do a guy like that. And now you have a very basic sketch, but nonetheless something you can recognize of what y equals x minus 4 cubed plus 1 would look like. Let's try another function. Suppose I wanted to sketch negative x plus 1 to the 6, take away 3. Well, I hope you would say the building block is that guy. That's who you start with. And then move it to the left 1. And that is what I call a negative on the outside. And we know that when you see negatives, it involves some type of reflection. And hopefully you'll recognize that when the negative is on the outside, that it is a reflection in the x-axis. And then finally, this piece. So here we go. I'll start off with x to the 6, and x to the 6 looks just like x squared. It's just it's more vertical. Its y values are much bigger, but it's still got that shape. Oh, I should have done it in dotted line, but nonetheless, too late now. Move it to the left 1, which means it's take the point there and move it to here. So your guy would look something like this. And that's what x plus 1 to 6 would look like. Then reflect it in the x-axis. Okay, if you take this shape and you reflect it in the x-axis, you end up with this guy. And then this guy, you move it down 3. So you take this guy, you move it down 3, which is about here. And then can you imagine that it's probably a good idea to do all of these in very thin, faint pencil? Because here is our final curve. G of x is this guy here. Negative x plus 1 to the 6, take away 3. I hope this is of help. And that's it for this question, or for this section. We'll be doing the other two shortly.